In this video, I'm going to give you a very quick introduction to difference in differences, which is one of the causal inference techniques that are very commonly used in the context of marketing. So specifically, I talk about marketing analytics in this channel. Go subscribe to it if you haven't already and if you like my content. So if a particular campaign or any initiative has been launched, like a change to a website, and you want to measure its impact, like what exactly changed, did it really have any significant impact? That is something that you can measure using difference in difference. It's a very simple concept. So this is what the equation really looks like. It's comparing the change in outcome over time between a treatment group and a control group. So that's what difference in difference really means. Using this, you also construct a regression analysis. The equation will be something like this. And we're going to talk about how this plays out, and we're going to look at a couple of outputs just to understand how to interpret it, because a lot of people have asked me, like, how do I see it as any different from naive observation, naive before after analysis? So let's actually look at these nice little graphs. By the way, what I've done here is used a certain package called Diff-in-Diff by Isaac Gerber, a very known data scientist. He created an open source package in Python, which is in GitHub. I've left the link to that as well in the description. So that's what I've leveraged to build this one here. So what in front of you is 4 charts. So first of all, there's something called a parallel trends. We have to understand that the major difference between any naive observation and a sophisticated structured approach, which is informed by data science techniques or data science knowledge, is really the core assumptions and the kind of validation that we can have in place in order to ensure that our observations are correct. So apart from, of course, the intricacies of the technique itself, in this case, as you could understand, like, it's a relatively simple concept. One could easily say that, hey, I can actually have a holdout group and I can just measure the differences. So basically do a before after analysis. But how do you do that before after analysis? Like, this equation itself is a before after analysis, a temporal difference in outcomes between treatment and control, but just that is not enough. One of the most fundamental things is that you should not have what's called a violation of the parallel trends assumption. So what is the parallel trends assumption? This is what basically sets it apart from a naive observation in the case of difference in differences, among other things, but this is one of the major things. So the parallel trends, again, conceptually very simple. It simply means that before the treatment was given out to the treatment group, there was a parallel effect in place, meaning that the data pattern would be fairly similar and moving in parallel between the treatment and the control groups in the pre-period. If you look at this first curve here, you'll see that it's more or less very obvious, right? Visually, you can understand that it's actually parallel in the pre-period. That dotted line and anything left of it is the gray zone. Within that is basically the pre-campaign intervention happened at the time of the dotted line. Take the x-axis numbers as weeks or maybe months. So somewhere between the 6th to 7th month, there is a campaign launch. And immediately after that, there seems to be a spike, right? Because of course it might take a little while for the effect to come in place, but that there's a spike in the one which is mentioned as campaign. So basically a new campaign, so you can say that it's a treatment group, and then the control more or less follows a very similar trajectory. So the difference between these two, that's actually going to give you your lift, or you can say your incremental lift as well. So Diff-in-Diff is very good for incrementality testing precisely because of this. But let's come back to the parallel trends assumption again. For instance, there are placebo tests that you can do, that you can like fake a test prior to the actual intervention period and then see whether or not there was any spike in the treatment group, which would have meant then that the treatment group actually experienced a spike or a major shift in outcomes even before the campaign launched or the intervention happened, meaning that the intervention cannot therefore be given full credit, at least for the post campaign or the post period change. But let's look at the right hand side of this chart here, of this combo chart. The right hand side shows you a case of pre-trend violation. If you look at it at first glance, these two look very similar even in the pre-period. That's how I deliberately created this simulation. Somewhere around the 7th month campaign was launched. So the pre-period is from the 0th month to around the 7th month, and you'll see that in this period, in the right hand side case also, they look fairly similar, right? One might be tempted to believe that these are parallel. So I work with a lot of real marketing projects, performance marketing projects, with brands spending up to $1 million a month. So for these mid-market brands, it's not very common, and perhaps for any size brand rather, it's not very common to get control and test markets which will be so similar in the pre-period, like it's given in the left-hand side chart here. So it's not very uncommon that you would get something like this, which is on the right hand side. but this is a violation. This is not clear only from a visual inspection of it, and that's why you will have to go to the next layer of charts, which is given by the bottom two. So these are called event study charts. So by the way, the first two charts on the top, these are called trend charts because they are simply the pre-period and post-period, they're just plotted, right? So these are just time series charts, normal trend charts. But if you go to the bottom two, they will give you a better understanding. So for the clean case, which is where the parallel trend assumption actually holds, that's where you will see that, yeah, it's giving expected outcome. So let's understand this event study chart here. In the y-axis, we have the estimated lift, which is simply the difference between the treatment and the control. So the difference between the treatment and the control is fairly stable, right? It's not just about the stability. In each case, it includes 0, which means that there is no significant difference between these two. But in the post-period and the post-campaign phase, you will notice that none of these are now including zeros. None of the confidence bars for each of these lift data points, they actually pass through the 0 line. So this gives them very significant differences. And this is a classic case of a proper clean case where the parallel trend assumption actually holds for difference and difference. Quite a mouthful, right? Parallel trend assumption. But if you look at the right hand side chart and the left hand side of it, you will see it's not as easy because it's going up and down. But that's just the first point. If you look at month 2 and 3, the lift is actually significant. So basically there is a negative lift in this case, but the point is that it's significant. It's not really going through 0. The point at 2, for instance, it is almost touching 0, but it's still not quite. So this means that these are significant lifts, and therefore there is a bit of a problem here. Clearly there's a violation of the parallel trend assumption, you can say. And there are some others which are going through the 0th point, but there's just too much complexity here. On the right hand side, of course, we have that lift again, but yeah, unfortunately that's not going to be enough. We cannot judge it only on the basis of this. This is the science that I'm talking about. This is basically what sets difference in difference and other similar causal inference techniques. I just took the case of difference in difference because it's probably the most intuitive and easiest to understand for those who are new to it, to scientific measurement, let's call it that, marketing measurement, or certainly causal inference techniques. But yeah, this is the case with other causal techniques as well, that the assumptions and the validations and the methods to ensure that the violations are not taking place, those are as much or as important, just as important as the core methodologies of the technique itself. In this case, the methodology is very simple, like you saw, like it's just a basic difference. The equation at least is very different. In reality, you have to run a regression in order to get the proper lift estimates, but the core mathematics of it is just that difference between that counterfactual and what actually happened that gives you the lift. So hope this was useful. This is a sort of an exposition. This is a demonstration of how to understand the core assumptions and why this is so important and fundamental to the technique, and why this helps set it apart as a much more robust and much more reliable technique than just naive observations, than not relying on in such technique but just doing a simple difference in difference without the technique and the science behind it. So that's it for this video. I hope you liked it. If you have any questions, if you want any future videos on any similar topics, do let me know in the comments, and anything else at all, always happy to engage in conversations. Once again, do subscribe to my channel. I make a lot of content around marketing measurement and marketing analytics, helpful to both marketers as well as analysts, practitioners in the marketing data science space, as well as other data scientists who want to work in the marketing space. So yeah, do check my channel, keep an eye on it for such new content, and I'll see you in the next one. Thank you.